Just like with adding polynomials, subtracting them will work in a very similar way because you're still kind of matching up the like terms, except obviously now you are going to be subtracting. And so remember, when you start a problem and it looks like this, and you've got an expression in the parentheses, and then you've got another one, make sure that you do not forget to look between them, okay? Because that's what tells you what to do. So in this problem, when I look at it, I've got a parentheses or an expression, and then I have something between them, and then I have another parentheses. So in this problem, I know I'm subtracting them, okay? And so it'll be very similar to adding, but when you're subtracting them, a lot of people have a tendency to make more mistakes. And so to help with that, you might have heard this in another class, but people do it kind of one of two ways. They're going to use a little trick, and people call this different things. You can call it, if you want to call it what you've called it before, you can do that. Or I know it as the keep, change, okay? And we'll talk about that in a minute, okay? That's a way to do it, or do the subtraction, so that you do not make mistakes so easily. But what this is essentially doing when you do the keep, change, and like I said, I think some people might call it keep, change, flip. But what you're doing is it's actually going to take that negative, which is technically like a -1 times this, and it's going to distribute that negative to everything that's in the second parentheses, okay? And so it makes it an addition problem. And then you can do it just like the other problems that we've done with adding polynomials, okay? And so either way you want to think about it, it works. So if we were subtracting two polynomials, you are going to start with the keep, change, okay? So what that means is you're going to keep the whole first polynomial or expression the way it is. So we're just going to take it and copy it down exactly like it is, okay? Then you change the sign in the middle, so it's going to become a plus. And then you change all the signs of the terms in the second one. And make sure, a lot of people for some reason miss one of these, and so make sure you kind of look at how many terms there are. So remember, the plus and minus signs separate your terms. So you look at all the terms and you change the sign of all of them. So this 5x to the third will now be a -5x to the third, okay? And we'll talk about what that is in a second. Then that +2 will become a -2. And then the -4x will become a +4x, okay? So now right here, if you could actually get rid of the parentheses at that moment, which you will see if you watch other videos, you'll see people do that. But right now, if you did get rid of the parentheses, adding a negative would actually be the same thing as subtracting, okay? But because in a lot of the problems that we do, they'll leave it in parentheses, we're going to leave it in parentheses, okay? So then from there, it actually makes it a really easy problem, because now it's an addition problem. So just like what we did in the other video, we just find our like terms and we now add them, okay? So I'm going to run through that. So 3x is a like term if I look with the +4x. So I'm going to put those together. So we've got 3 + 4 is 7x. And then I've got -4x to the third. And I'm going to look and see if there's a like term there. That's a like term with it. So I've got -4. Make sure you remember to look at the sign in front of it. -4 plus -5. So that would be a -9. And then remember, the last name stays the way it is. And then I have 4, and that will be a like term with that because they're both constants. So we've got 4 plus -2. So that's like 4 minus 2. So that ends up being a +2. And then make sure you didn't miss anything. And then after that, remember, you have to look at your polynomial or your expression, and you have to make sure that it's in standard form. And notice when I did this one, I should have looked ahead and I would have been able to put it in standard form right away if I kind of looked at that. But if it's not in standard form, remember, you take the terms that have the highest degree, and you list them from highest to lowest degree. So this one right here has the highest degree. Remember, you take the sign with it. So it'd be negative x, or negative 9x to the third. And then the 7x has the next one. So it's a positive 7x. So I'm going to put a plus in front of it. And then I have the plus 2. So there we go. So we're going to do one more just so you can see another one. And then I'll let you practice. All right. So with this one, I have a parentheses, I have a minus, and then I have a parentheses. So I know I'm subtracting these two expressions. And so from there, I'm going to do the keep, change, change. So you keep the first one. So it'd be 4x squared minus 2x plus 1. Change the sign in the middle. And then you change the signs of all the ones in the other one. So that would be a negative 3x to the third minus 2x squared plus 4x. All right. So from here, and remember what that's essentially doing is it's taking that negative, which is like negative 1 times that, and it's distributing it, which we will talk more about that later or in another class. It's distributing it to that second parentheses, okay? And so now it's made it an addition problem, and then we combine like terms. So with this one, I'm going to look ahead because in the last one, I had to rewrite it. But if you look ahead, you don't necessarily always have to rewrite it in standard form. So when I look at my terms, I notice that the highest degree here is the one with the x to the third. So the third is the one that, the x to the third is the term that has to go first. And so I'm going to actually start there, which is kind of weird, but it'll help you so that it's already in standard form when you're done. Okay, so I'm going to look, is there any other terms that have the x to the third? And no. And so if there's nothing else that will combine with it, you just bring it down. And so that one's going to kind of just float down. And if you are a very visual person, one thing that you can do is kind of mark them out as you deal with them so that you don't repeat any. And then from there, the next one that I see that's the next highest degree is the x squared terms. So I have that, and that's a like term with this one. And so I'm going to combine those. So we got 4x squared plus negative 2x squared. So that's like 4 minus 2. So that's a positive 2. And then remember that last name, the last part of it just comes down with it, okay? Stays the same. So then we're done with that one. So again, if you're marking them out, you can mark it out as you go. And then the next one that I see is the x terms. So we've got negative 2x plus, and then that's a like term with that, so plus 4x. So negative 2 plus 4, that ends up being a positive 2. And then the last name is x, so it'd be positive 2x. And then the last thing that I see, so I gotta mark that out. The last thing that I see is the 1, and there's nothing else with it, or that'll combine with it. So just like we did that first term, I'm just going to bring it down. And notice, because I looked ahead, it's already in standard form, and there's nothing else that's like terms that will combine. And so that's my answer.